Chapter 8.1 notes, Part 2. We started them yesterday. We're right here where we do the show for converting the mixed number into an improper fraction and then solving. So, the biggest thing is I just want to make sure we don't make the silly mistake of, some people go 1 minus 1, 1/4 minus 3/4. You got to make sure that you make it improper so that you guys have similar fractions, common denominators, and whatnot. In this case, it's kind of nice because they are going to be common denominators, but also you have to understand that it's multiplying to the y. So what we're going to do here is 1 times 4 plus 1 is 5. So this should be 5/4 is our first step here. Yep. 1 times 4 is 4 plus 3 is 7/4. So this is what we have. Negative 5/4 equals 7/4. Right, so now we want to divide this over. And then I like to write it here so you guys can see we're going to flip and multiply, right? Okay, so this is gone. We have y by itself, so we're happy with that. When I flip, I multiply 4 over negative 5. It doesn't matter where the negative's at. But again, you can multiply straight across and reduce if you want, but you should see there's a 4 here and a 4 here. You can cancel that. So your answer is simply negative 7/5. I was asked this yesterday. This does not matter. 7/5. All these ways of writing negative 7/5 is correct. You can write any of those 3 ways, they're all right. Okay? So they all stand for negative 7/5. Okay? Most of the time, these 2 are the preferred. Very rarely do they put it on the bottom. But if you did, I wouldn't dock you because it still means negative. Okay? You guys good with that? Okay, so let's check our work here. So remember, it's easier to check your work on these plugging in after you already made your common denominator, or excuse me, your improper fractions. So negative 5/4 times negative 7/5 equals, 7/4. So when we times these, you can see the 5s are going to cancel. A negative times a negative is a positive 7/4. So you're good. So I did there again, and I think, don't let me mess you up here. I think Brett, you didn't like to do this cross thing, but if you only do this cross thing, I'll do that for you over here. Negative 5 times negative 7 is 35, a positive, because negative times a negative. 4 times 5 is 20. That's what you'd get, and now you have to reduce that. Okay, number that goes into 35 and 20 is 5. 35 divided by 5 is 7. 20 divided by 5 is 4. Okay, so either of those methods are correct. Okay, are we good? Okay. All right, so now we got decimals. So decimals are a little bit easier if you want to use your calculator for a little bit more. Okay, so this one's still pretty simple. How do we get rid of negative 1.2? Yeah, we just got to divide it. So you would just do that on your calculator. That's fine. What is it? Thanks. 3.3 is your solution. Okay, to check it, negative 1.2 times 3.3. You do that calculation, you'll get, oops, not 9. You'll get negative 3.96 equals negative 3.96. Okay. Are we good? Kind of going through these ones a little quicker, a little bit more basic. This one down here we'll focus on though, okay? But go ahead and try the show you know here. I'll give you a second. Go ahead and try that one. Make sure you get that one right. All right, so first thing to do, divide by 5.5. What do we get for that one? It's going to be a decimal smaller than 1.
0.62, negative.
Okay, negative 0.62, perfect. Now we're going to check it. So we're going to go 5.5 times negative 0.62 equals negative 3.41, and then that calculation should match up. Okay. All right, so for part B here, this is a lot of times where we get messed up, and even in my higher level courses, for whatever reason, I swear it's like it's almost like a malfunctioning. Okay, when you're in like a calculator malfunction or a computer malfunction, you just like you see the fraction bar and your brain just goes locks up. Like I don't know what to do with that. Yeah, and it's just division. That's exactly it. Okay, when you see this bar, that means division. That's all it means. We were just doing multiplication, now we're doing division, so the opposite of division is multiplication. So we're just going to times 0.28 to both sides is all. And I know that sounds simple, and I'm sorry if I'm making it seem harder than it is, but when people see the fraction bars, they simply like, oh, I don't know what to do with that. They don't even think about it. Oh, I don't know what that is going to be. Okay? So all I'm saying is this is the problem. It's being divided. Opposite divide is multiply. So I put multiply here, so that makes it cancel. Okay? So R is going to be, what's that going to be? Almost 0.3, so it's going to be like 1.4. What is it? 1.26? Negative 1.26 would be R. Okay? So the step there when you have a dividing bar, a fraction bar, is to multiply to get rid of it. Okay? Perfect. So we have R equals negative 1.26. Perfect. Okay, and we're going to check it now. So we're going to go R, not R. We just found R. Negative 1.26 over 0.28. Equals negative 4.5. And then it should, the calculation. All right. Show you know here. Okay, so this one here, we got to multiply 1.3 to both sides. Okay. What's that get you? 1.04? Yeah, that makes sense. Okay, then we're going to check it. We just verified it. So the decimal works a lot more like calculator work, but just knowing the steps to do. Okay, when you have the fractions, guys, like the ones from before, those you're not going to want to do the calculator. I will tell you, and we will talk about this in 8.2, if you get very calculator dependent on these, when you're doing a fraction one, when could you run into trouble? Does anybody know? Yeah.
Like if you're trying to convert the fraction into a decimal.
Yeah, you can do that as well, but I'm more talking about your answer can be slightly off if you do this. Rounding. Very good, Jade. If you get, for example, 1/3, I'm getting off track here, but 1/3 is 0.3 repeating, right? So if you get 1/3, and then what are you going to put? You can't put 0.3 repeating, so you'd probably round that to 0.3.
But that's wrong.
But when you go to check it, you'll be wrong. Exactly. So when you're doing the fraction ones, you really need to be good at staying in fraction form, because if you keep it in fraction, it'll be exact. If I use 1/3, that is 0.3. But if I use 0.3, I can't use that decimal because it's repeating. Does that make sense? So what I'm saying is don't just say, oh, I'm just going to my calculator all the time and use decimal, because then you're going to get things a little bit wrong, okay? So making sure don't avoid the fractions. We should be hopefully getting better with that. All right, let's look at these two kind of applied problems here. All right, Canadian football field is 137.2 meters long. It's too big. Okay, horse gallops at a speed of 13.4 meters a second. How long will it take a horse to gallop the length of the field? The formula for speed is distance over time, right, Logan? Speed equals distance over time. He's just doing that a little bit ago. Okay, and so we're going to figure out how long it takes the horse to gallop. So he's going 137.2 over t. T is what we don't know, right? We don't know the time. Does that make sense? Okay, and then the speed is 13.4. It's a good question. There's two different ways you can do this. But, Luke, you've identified the problem. The problem is our variable's on the bottom. We don't like that. Okay? So I'm going to show you two different ways. We'll take a little class vote, and then I'll keep you guys going that way the rest of the time, because I don't want to mix you up. Here's one way. It's called flip-flip. So 13.4 as a fraction is over 1. So then we can take these and we can flip both of them. What we do to one side, you can do to the other. So I'm going to flip it to, whoa, oh, that's not a cheat pen. Okay, that's going to be 1 over 13.4 equals t over 137.2. And now we can multiply that. So we made this over 1 because it's a whole number, or not quite a whole number, but it's over 1 as the way it's written. We flip both of them. And now we're going to multiply 137.2 to this side. And so t is going to be 137.2 divided by 13.4. The second one? Okay, so I multiplied this over, right? There we go with that. So this canceled. That goes, when you multiply, it goes to the top. So I just put t in front. 137's on top over 13.4. So you're going to divide this for your answer. Yeah, I'll show you. What's this answer first? 10.2? Okay, so 10.2 seconds is how long it takes the horse to gallop the field. Okay, here's the other way. Okay, so I'll keep the same setup. I have 13.4 equals 137.2 over t. Okay, again, the problem is we don't like t on the bottom. So we're actually going to multiply t to the other side. Everybody okay with that? So I'm multiplying t to both sides. That's gone. We now have t off the bottom. And you can see now it's an easier decimal problem. Because now what do we do? No. Divide 13.4. That's all right. Easy, easy. Okay, and you can see, guys, we got the same thing. So the second one is moving the variable. The first one is not moving the variable, essentially. Okay, easier to follow. All right, so just a quick vote. We'll say this is 1, this is 2. Who wants to do 1 from here on out? Okay, we got 3, 4. Yeah. Yeah. The other thing, guys, if we're being honest, if you're getting it written like this, you essentially can do this. Flip those. They essentially switch spots. Yeah. Does that make sense? Yeah, I was just writing it out just so we could see all of it, but yeah, I was being a little bit redundant. Yeah. So what I'll do is, guys, I'll stay with this one. I think in general I'll stay with this one, but in general you guys are seeing the pattern. It's really they're just switching spots. Okay, sure. Yeah, I'll do the first one every now and then if you want. Okay, so this one here, a musher and his dog traveled 23.5 kilometers an hour with a dog sled race. How long? So we're given the speed again. So it's 23.5 equals 50 over t. So again, essentially these are going to switch spots. Okay, so I'll just, for Connor here, I'll do the 1 here. We'll flip it. So okay, so 50 over 23.5. Should be like 2.1, 2.1, okay. So 2.1. So it'll take 2.1 hours to travel 50 kilometers. Yep. Yeah. We said, wait, warehouse not 0.25, sorry, no. I'll show you. Winter warehouse has a winter jackets on sale for 25% of the regular price. The jacket price is $176. What was the regular price? So if you times it by 0.25, that's how much you save. Oh, 1.25, then you're gaining. Okay, so you guys are, this is really good. You're saying the right things. And you knowing to add 25% is going to help you in the future, but not for this problem. So how about this, guys? Just think about it. If I'm buying a jacket and it's 25% off, how much am I paying? 75%. So 0.75 is what you multiply by. So this is how, hold on. You guys are all saying good things. Let me say one thing. 100% means you what? You pay full price. Right? 100%, yeah, no one wants that. So, Connor, just the way you said, if I did 1.25, that's 125%. So you're actually paying the sale price on top of the original. Is it a sale price? No. Oh, okay. Yeah, so I see. Nope, he's right. This is a sale price. I overlooked that. So Connor is right. So let me get to what I'm saying here first, and then Connor, I think you are right, actually. So I see what you're saying. Okay, so 100% is the real price. 125 means you're paying over. 75% means you're paying 25% less. Okay, all those as decimals is 0.75, 1.25. So back to what Connor was saying, because he's reading the problem better than I was, okay, is that we have a jacket sale price is 176.25. That's how much it is on sale. Okay. So sale price is our S, or excuse me, original price. I want to go, let's go R for regular price. So what do we times regular price by to get sale price? This is a sale price, right?
We're trying to get the regular.
So we're trying to get regular, so that's our variable. What will we multiply regular by to get this?
0.25.
So it still is 0.75. Correct. We will divide it. You're exactly right as well, Luke. Right? So if I divide by 0.75, that's going to make this a bigger price, which makes sense. We're going to find the regular price. I know, I lose you. Okay, so right here, this is the price of the jacket that you're going to pay after they say, yo, it's on sale. You got it for this. You're like, oh, how much would it have been if it wasn't on sale? Well, regular price, it was 25% off, which is 75% is what you paid. So if I paid 75% of the regular price, I get the sale price. Okay, so 0.75 is 75%. I times that by the regular price will give me the sale price. So to solve for the regular, I just divide the 0.75 to both sides, which makes sense because, guys, when, like Luke said, when you divide by a number less than 1, what happens to the number? It gets bigger, which the regular price should be bigger, right? Okay, yeah. Okay, yeah, I know what he's doing. He's doing a little fraction work. Yes, I think you could. There might be some rounding thing to be careful with, Cato. But I think, yes, you could do that. So what he's saying is, because we knocked off a quarter of it, so we have 3/4 left, so he's figuring out how much a quarter is. Okay, very good. Jade, did I still lose you, or are you okay? You think you're okay? So let me read it to you one more time. Sale price is 75% of regular price. 75% of regular price means 25% off. Okay? When you divide these, you're going to get a bigger number. And what's that number, guys? Just straight? Yeah. Okay? So regular price was $235. So a couple things you'd know. I got this wrong if my price was smaller. Right? If I got like 120, that doesn't make sense. Okay, stuff like that. So making sure you understand the context of the problem. All right, we have anything on the next page? We got one more. Okay, last one. Let's try this again here. It's another price one. Okay, Winter Warehouse is selling mitts at 30% off the regular price. The sale price of mitts is $34.99. Again, it gives us a sale price. What's the regular price? So we'll let R again be the regular price of mittens. They've done this for you this time. 100% minus 30% times the regular price. So the equation would be $34.99, that's the sale price, equals 0.7 for 70 times R. Okay, and again, we'll divide by 0.7. The regular price of the mitts is So we'll say 49.99. I think is what probably was supposed to be. 49.99. Okay. All right, guys, that's it. Guys, honestly, that was a really good lesson. You guys asking those things is